welcome again. We will see the insert operation in a linked list, that is a single linked list. So for any data structure we have various operations: insertion, deletion, search. Okay, so printing the data structure. So we can perform such insertion also on the linked list. So insertion can happen in three ways. So if this is a linked list, we can insert from the front side, that is a beginning, insert from the front end, beginning, or we can insert at the last also, at the end, or we can insert in between somewhere in the list. So there are three ways we can do the insert operation: insert at beginning, insert at end, and insert at in between. So we'll see one by one. So this two line of code is responsible for insert at the beginning. So advantage of linked list is that so insertion and deletion operations are easy and efficient. How they are efficient? Because changing one or two pointers here and there will make the list change according to the pointers. Okay, so we'll change some pointers here and there and we'll do the insert operation. Same way in deletion also, we'll change some pointer here and there and we'll remove a list node from a list. So unlike arrays, where in array if you want to delete some element, we have to start with the first location and then we have to go reach to a location, then we have to delete, then we have to do the shifting of elements and like. So insertion, deletion may be time consuming in arrays, but in linked list it is easy and efficient. So let us see the insertion at beginning. Let us assume we have a single linked list with two elements, 10 and 20. Okay, so and we want to add this third element, which is a node and which stores value 30 at the beginning of the list. So this will be our final output which we are seeing. And to get this output we require these two important lines of codes. So here we'll just write a code: temp equal to malloc, and then we'll allocate size of struct node star. A temporary node will create, and in that temporary info we'll add a data, user data, which is 30, and then we'll make the pointer part as null. Now this is a newly created node and this is our previous already we having a linked list. Now we want to connect this node at the beginning. So what should be there? So this node 30 should come before 10. So for that, this node 30, which is now pointing to null, should point like this: temp ptr should point to the start. Okay, so this is nothing but the first line. Temp ptr equal to start. So temp ptr field should point to start. Okay, and now this is now pointing to the node 10. So 30 pointing to 10, 10 pointing to 20. Means what? Now 30 is our first node, but it is now not pointed by the start. So we have to update the start. And how to update the start? We'll make start equal to temp. Okay, now this start will point to temp. Okay, so now this start is nothing but 30. Now 30 is pointing to 10 and 10 pointing to 20. Okay, so this is nothing but this structure. Start is 30, 30 is pointing to 10, and 10 node 10 pointing to 20, and 20 is rounded. So this is the insertion at beginning with the help of these two important lines in the code, C program code. Next is insertion at end. To insert at end, suppose we have given a list of two elements, 10 and 20, and we have to insert this newly created node 30 at the end. So for insertion at the end, first we have to reach the last node of the list. Okay, so here the last node is 20. So what is a special case of last node? In the last node of the list, the pointer field is null. So this logic will help us to reach a last node. Once we reach a last node, we have to make that last node to point to the temp. So temp is our temporarily created node. Once this will point to temp, it will be appended at the end and it will become the last node of the list. So for doing that, first we have to reach the last node of the list. For that we have to have these two lines of code. We'll take a pointer variable q and we'll assign it with the start. So q will start from here, and we have to go from node to node like this, from one node to another, and we have to check till the node is having null value in the pointer field. So QPTR value, if it is not null, we are moving ahead. So this is a Q, so this is our Q. Its QPTR is null, so 10 PTR is pointing to somebody else, so it is not null. So Q is equal to QPTR. So Q moves ahead. So now this becomes Q. Now this is a Q. So we'll check QPTR is not null, but it is null. So Q will stop here. Okay, Q will stop here. So once Q stops, we know that this is the last node of the list. Now we want to add this at the last in the list, at the end of the list. So we reached the last node of this list, so which is 20. Now we just want to update the pointer that this is now Q, 20 is now Q. So we have to just update QPTR field to this field, that is a temp. So that is this line QPTR. So this is our Q and this is the PTR field. So QPTR will point to the temp. Okay, so once it is pointing to 30, the structure like this will be created. So this is a structure which is now created. So we first reached the last node and called it as a Q, and we have simply made QPTR, so this field, to point to temp. So QPTR will point to temp and insertion will happen at the end. Next is insertion at specific location. Here we'll ask user where you want to insert a data. So user can insert in between anywhere. So after 20, after 10, after 40. Okay. So in between you can insert the data. Here whatever is there links in a black line are the original list, and the whatever is there in red, which is the final after insertion at specific location. Here we'll ask user for a val. Val is a very integer variable where user will insert a value, will say 20. So whatever user want to insert, that should be after 20. Okay. So after 20 there should be a new node and not 40 should be there. So after 20 a new node will be added and that new node will point to 40. So the new list will be 10, 20, 30, 40. The previous list was 10, 20, 40. Okay. So how for doing that we require to reach a node with val 20. To reach a node with val 20, this line of code is used. We'll have a variable q from start. So q equal to start, we'll start from the first node, and while that q info is matching with the value 20. Okay, so that matching with the value whatever user entered, so we'll go on to the next node. Q is equal to QPTR. So Q is equal to QPTR, this line of code takes us to the next node. Okay, so Q will start from here, then it will match with the value 10, so it is not 20, so it is not matching with the value which is a 20, so we'll go ahead. So Q is now here. Now Q info is 20, which matches with val, so Q will stop here. So this is our Q. Okay, once you find the node for after which the node should be inserted, so here we have created a temporary node 30 which is to be inserted after val, that is a 20. So for that these two lines of code will be used. So this temporarily created node now will be inserted between 20 and 40. For doing that we have to update two pointers. So that two pointers which we have to update are shown in a red color dotted lines. Okay, so this link will break now, and the temp PTR. So temp PTR. So this is the temp, and this field is a temp PTR. It should point to the next of Q. Okay, so this line temp PTR means this field will point to the Q PTR. So Q next means Q PTR. Okay, so this red color link is nothing but this line temp PTR equal to Q PTR. So this is the temp PTR which points to Q PTR. So this is nothing but Q PTR, Q's next value. And once this is connected, we have to do this connection. This is nothing but Q PTR field, and it is now pointing to the temp. Okay, so this is line Q PTR which is now pointing to the temp. And with these two changes in the pointer fields, we have inserted 30 after 30 node after 20. So this is nothing but insertion at specific location.